Yes. So this 65% is the weighted average between 60% and 72%, right? So that's what you have. Don't worry about Q1 being given. First find Q1 by Q2, right? You have 60, 72 and 65, which gives you a distance ratio of 5:7, which gives you a weight ratio of 7:5. Now this 7 corresponds to 280 people, right? So 5 corresponds to 200, which is the answer. Is that okay? Anybody was a doubt or something? Was that a reply to is that okay, or do you have a doubt? Anybody has any doubt or any confusion, please bring it up. No issues. Like, I am actually not used to taking this sort of a session where I don't hear any voice back. It's kind of unnerving as well. So feel free to ask as many doubts as you have, right? Can I move on to the next question? Guys? Hello? Can I take the next question, guys? Hello?
Hello?
Yeah, is there, okay, 60% of the boys, do you have a doubt?
Yes.
Yeah, tell me.
There are only 60% of boys got distinction.
Yes.
But there are total of 280 boys.
Yes.
What you have done that you taken the 280 boys as as distinct, who got it distinct, but
yes. So tell me.
You got my doubt?
I didn't understand your doubt. What's the problem? You're saying that 60% of the total is, no, see, it's not 60% is equal to 100, 280. Total number of boys is 280. Total boys. Right? Yeah. Out of that 60% passed. If you want to analyze this question with the actual numbers, right? This is a question where you have 280 boys, right? Of which 60% passed, which would be how much? 60% of 280 would be 280 into 3 by 5, 56, 168, is it? 28 into 6, 84, 168. Yeah, 168 boys got distinction, right? And we don't know the number of girls. You can take it as 100x if you want, right? Let's do it algebraically as well. Out of that 100x, 72%, that would be 72x, got distinction, right? And what we're basically saying is that you have your how many distinction? 168 distinction plus 72x distinction among girls divided by the total number of students, which is 280 plus 100x. This should be equal to 65%, right? Let's simplify this. 13, 20, 2 into 168 would be 336, 336. This is unnecessary, right? You see how unnecessary this is. Can we simplify this further? 3360 plus 72 into 1440x is equal to 28 into 13. How much is that? 28 into 10, 280, 28 into 3, 84. 20 plus 84, 364, 3640 plus 1300x, right? You're going to get 140x is equal to, you can talk to me, Del. I don't think it's necessary to make you present for that. If you have a doubt, you can just unmute yourself and ask me. Is that fine? Hello. Yeah. See, the point of it is, once you do the whole thing, you're gonna get x is equal to 2. That will give you 200 students, right? This is time consuming, right? Whoever has the doubt, it is not necessary to find the answer, right? You can just look at the weighted average and get the idea directly with a smaller computation, with smaller numbers, the same answer. That's the point, right? Del, what's your doubt? Hello. Yeah, you can unmute yourself and ask me the doubt. Okay, fine. Which leads us to one more question basically. One second. Right. Yeah. Just ping yes if you get the answer. Okay, the question is basically saying that he averages 35 when he bats first, and he averages an unknown number when he's batting second, when his team is chasing. But the overall for the entire tournament was 41. And out of 8 games, 5 games they batted first, 3 games they batted second. Using that, find the average while chasing. Given that he has gotten out on every occasion. Okay, I think 1, 2, 3. Cool. Do you guys need any more time? Yes, yes, everybody's getting. Cool. So what's the answer? Not 57, 51, perfect. Yeah, 51 is the answer. It's pretty simple. You have 35 batting first, 41 is the overall weighted average, and there is an unknown number. So R2 is the unknown number right now. And we also know that they played 5 matches batting first and 3 batting second. So when you invert the ratio, you'll get 3:5. This 3 corresponds to a distance of 6, so this 5 should correspond to a distance of 10. Your average will be 51. Is it okay? Everyone? All right. Now this is just a demonstration of what you can do with. I mean, what are the parameters, right? We talked about the parameters. You have your first rate, your second rate, your weighted average, and your weight ratio, right? Any one of these could be the unknown, and we looked at examples of each one, right? But beyond this, what makes alligations interesting and what makes it useful to learn at the beginning itself is the fact that there are so many applications outside of direct mixed questions, right? We're going to look at those after this. Before that, anybody has any doubt, please let me know. You can unmute yourself and ask. Anyone? Cool. Yeah. If you can ask me which part of this you had a problem with, I can explain that. If you can tell me. You can unmute yourself and ask me. Should I repeat the whole thing? Done? Yeah, cool. So what we see, understand what we have and what is required. That's the most important thing, right? We have R1, we have weighted average, we want R2, right? We are given Q1. Q1 is this thing right here, right? Q2 is not directly given, but Q2 is basically 8 minus 5, right? Is equal to 8 minus 5 is equal to 3. So you have 5 innings where he batted first, 3 innings where he batted second, and he got out every time, so you don't have to worry about not outs interfering with your average, right? So what we have here basically, one second, just going to do this. What we have here basically is a number line where the left extreme is known to us, the right extreme is the unknown, and the weighted average is 41, and the weights given are 5 and 3. Fine till this point? Yes. So you know that the distance ratio is going to be the reciprocal of the weight ratio, right? And this 3 parts corresponds to a total distance of 6. That's the distance between 35 and 41, right? Now 3 parts is equal to 6, then 1 part is equal to 2, and 5 parts is equal to 10, which means that is the distance between 41 and this unknown number, right? So that makes 51 your required answer. Hello, Ankur? Yeah. Ankur, your microphone is on. If you have a doubt, speak up or turn it off. Somebody, T7, who's T7? Okay. Is that fine, guys? Can I move on? Hello. Right. See, yes. You have plenty of applications in other chapters, but before that, one more thing. You have these mixture questions, right? In alligations, you have questions that are based on mixtures, right? Solutions, for example, or alloys, right? One important thing that you need to do, right? I'll give you a question. If you take this question right here, let's take this question, right? Okay. So you have two different alloys. Let's call them alloy 1 and alloy 2, right? Alloy 1 is A is to B in the ratio 2 is to 3, and alloy 2 is A is to B in the ratio 4 is to 1. And we want to combine A2 and A1 in a particular ratio to get A is to B in the ratio 1 is to 1, equal parts of A and B, right? The question is, what is the ratio in which I must mix A1 and A2? Now, the important thing to understand here is that I can say that this is the weighted average of this and this, fine, but this ratio is useless to me for calculating weighted average, right? Component 1 is to component 2 is what is given, and this is useless. Just remember this. Otherwise, this thing is very easy. What you need to do is take component 1 by total, or you can take component 2 by total. It's not going to make a difference. You can use either one, but you have to take something by total. 2 is to 3 is not the answer. Sorry, right? Give me a second. I'll explain. So we will first convert everything to A by total, and what you're going to get is 2 by 5 and 4 by 5, right? And the required A by B is actually 1 by 2. Right? A by total, sorry. A by B is 1 by 1, A by total is 1 by 2. So that's what you need to put on the number line, right? You've got 2 by 5 and 4 by 5 giving a weighted average of 1 by 2. Now I can just take this as 40%, 80% and 50%, which will make my calculation easier, right? So you have a distance of 10, you have a distance of 30, inverted, 3 to 1 is your answer, right? 3 to 1, perfect. Right, so this is all you have to remember with respect to alloys as well as solutions. Solutions also will be given like that. Milk is to water is in the ratio 2 is to 1, 3 is to 1. So 2 is to 1 will become 2 by 3. Remember this, and all these solution questions will be easy, right? So let's look at a couple more of these questions quickly, and then I'll introduce you to some applications in other chapters. Look at this question. You can also do this without using averages, right? That's perfectly fine. And if you find that more comfortable, please do that. No issues. Rudra, can you unmute yourself and tell me? Are you having a problem with the previous question? Rudra, was it the previous question or this question you're asking about? Rudra, if you have a doubt, you can unmute yourself and you can ask me, right? If I believe you're talking about the previous question. All right, it's here. Last part up to 2 by 5 is fine. Cool. So see, the point is, as I told you, you cannot put 2 is to 3 is 2 by 3 on the number line and 4 is to 1 is 4 by 1 on the number line. This will not give you the right answer, right? So component 1 is to component 2 is useless. Component 1 by total on the other hand is useful, right? So we have, you said you understood till 2 by 5, right? Up to 2 by 5 is fine. Perfect. So your first, your alloy 1 is basically containing a by total. Okay, understand. A by total is 2 by 5 in the first one. A by total is 4 by 5 in the second one. You need A by total to be 1 by 2, right? Then only will A is to B become 1 is to 1, right? So you're putting 2 by 5 and 4 by 5 in the on the number line at the ends, and you need 1 by 2 in the middle. Now basically what I did was just, see, you don't want to do 1 by 2 and 2 by 5. 1 by 2 minus 2 by 5 and write a denominator by 10. Right? You know that this 2 by 5 is 40%. Right? If you don't know your fraction percentage conversions, learn them, very useful. Right? You'll save a lot of time. Right? Which is why I said this. But if you're not comfortable with this, you can just directly subtract. No issues there. 1 by 2 minus 2 by 5 will give you 5 by 10. Let's just put it down to the same denominator. 5 by 10, 4 by 10, 8 by 10. So these are now the same numbers but with the same denominator, which makes it easier to subtract. So you have a distance of 1 by 10 here and a distance of 3 by 10 here, which are clearly in the ratio 1 is to 3, which means your weight ratio will be 3 is to 1. You need to take 3 times as much as the, of the first alloy, you have to take 3 times that much as the second. Yeah, perfect. Right? Right, one second. There's one more question. Wait. We're going to discuss this question. Right. How many liters of water should be mixed with 30 liters of 96% milk solution? So that's a milk solution containing 96% milk and 4% water. You need to get 90% milk and 10% of the water. So this is directly given in percentage, which basically means milk by total. Yes, 2 liters is the answer. Perfect. Right. Hey, everybody is getting really fast with this now. Okay, nice. So you basically have 96 is one component. So there's something here that's known to us that's not given explicitly. So we're talking about adding liters of water. Pure water is 0% milk and 100% water. So this is, if somebody got stuck in what is on the other end of the number line, then that is 0, because the water that we're adding is 0% milk. So we're looking at getting a weighted average of 90 using 0.96. That is a distance of 6 and 90, which are in the ratio 15 is to 1. So the weights are in the ratio 1 is to 15. Now we have given 30 liters here, so this will be 2 liters here. That is one way of doing it. Now if you want to just calculate the total amount of milk that is there in 30 liters and then add water, take X liters of water, that will probably give you the answer almost as fast, probably faster for some people, right? Doesn't matter, right? Does anybody want me to do the same thing algebraically? Hello, anyone? The question was, should I solve it algebraically as well? Is that necessary, or can we look at some of the question? Anyone? No. Okay. So let's look at another question. One more. So this is very similar to the question that we did a little bit earlier. It's just that the numbers are a little less easy to work with. Yash. Yeah, you were talking about the previous question, right? Hello, Yash. Are you talking about this question? Yes. Can you tell me where you're stuck? If If you can unmute and talk, that'll be better. I mean, that's convenient for both of us, right? So you have 90% is the required weighted average. It's just a matter of identifying what is what. This is one of the components, right? The other component is pure water. Pure water is 0% milk and 100% water, right? So this is my R1. R1 is equal to 0. R2 is equal to R2 is equal to yeah, R2 is equal to 96 and RW is equal to 90. Is that fine? Yes. Hello, Yash, is that okay? Can I continue? Okay, fine. So you put 0 and 96 on the number line, and 90 is the weighted average, right? So that gives you a distance ratio of 90 and 6, right? Which simplifies to 90 is to 6, simplifies to 15 is to 1. So that's the distance ratio. So the weight ratio becomes 1 is to 15. Right, and it is already given in the question that there are 30 liters of the 96% milk solution. So this 15 parts, when I say 1 is to 15, there are 1 parts of water to be added for every 15 parts of the initial solution, and the initial solution was 30 liters. 15 parts is equal to 30 liters, which means 1 part is equal to 2 liters. Just direct proportion. Is that fine, Yash? Yes, Ankur, very good question. You can also do the same thing with percentage of water. So that will look something like this. Nice, interesting questions are having. Okay, so you can basically say that I am mixing 100% water with 4% water to get 10% water. You'll see that you get the same numbers, right? 6 and 90 again. So this will again give you 1 is to 15, which becomes 15 is to 1, plus 15 on this side where there are 30 liters. And 1 on this side, which will give you 2 liters, it will give you the same answer. Good question, right? Is this fine at this point? Guys, everyone? Yes. Yes. Okay. Let me give you a couple more different questions. So now we have, okay, let's take one more question. Okay, Mr. Gale hits only 4s and 6s. He doesn't like running, right? And the rest is given to you. Ping yes when you get the answer. Nice. Anyone else got the answer? Sai, what is the answer that you got? Okay, anyone? Okay, fine. I think you were replying to the earlier question and I saw it late. Okay, so the thing here is that you have 3 terms. You have dots, right? You have 4s and you have 6s. Right? This is something that we didn't discuss. This is the primary disadvantage of the number line approach. You can only do 2 at a time. If you remember the explanation of why it works, we talked about F1D1 is equal to F2D2, right? And in that that example, we specifically took only 2 items, right? The number line approach works only for 2 items, but I'd like to add and say that it works for only 2 items at a time, right? You can still do 3 items, not a problem. You have to take it separately, right? Now, I think if you want to use a number line and solve this question, what you do is you will find the weighted average of the 4s and the 6s, right? He scores 4. This is again an average, right? 4 runs per ball, is what he gets from hitting a 4, and 6 runs per ball is what he gets from hitting a 6. And these 4s and 6s are in the ratio 1:3, which gives you a distance ratio of 3:1, which will give you 1.5 and 0.5 as the distances, which will give you 5.5. So from the boundaries alone, he is scoring 5.5 runs a ball, right? That's a strike rate of 550. Monali, I'll explain again. Anybody else is facing a trouble right now? Just tell me. Should I repeat the solution? I think I will. Right. So the idea here, how would we come back to this question? We'll come back to this question. I'm going to give you a different question. So again, you remember that cliched example of a shopkeeper mixing 2 varieties of rice. I'm going to take 3 varieties of rice. Okay, 1, 2, and 3. They cost 10 rupees per kg, 20 rupees per kg, and 30 rupees per kg. He has 3 varieties of rice that he's mixing in the ratio 2:3:5. Right? Now, what is the per kg cost of this mixture? You can, if you want, you can take it as 2 kg, 3 kg, and 5 kg, but it's not required to find the answer because you're asking per kg cost. Now, you cannot directly apply the number line here. You can directly apply the formula. That is fine. 10 into 2 would give me the total cost of the first variety. 20 into 3 would give me the total cost of the second variety. 30 into 5 will give me the total cost of the third variety. So this numerator is the total cost of the 10 kgs of 3 varieties of rice. You have to divide it by 2 plus 3 plus 5. Right. This is going to give you 20 plus 60 plus 150 by 10, which is going to be 230 by 10. Yes, and 23. Now, if you want to use a number line, what you would do, right? 10 and 20 on the number line, right? In the weight ratio of 2:3, which would give you a distance ratio of 3:2. Now, the reason why people are getting lost at this point, right? The crucial skill that you must work on to become efficient at alligations, given a ratio and a sum. The sum was 10 in this case. Finding the individual components, right? Components are 4 and 6, right? This is a crucial skill that you must become faster at, right? Without writing clearly. 3x plus 2x is equal to 10. We don't have time for that. When you see 3:2, immediately you must go, okay, the numbers is equal to 4. Therefore, the weighted average is 16. Now, if you are a little weak on this, practice this, and you will see the benefit when you're doing allation questions, right? So you got a weighted average of 16 for the first 2 components, right? Which are 2 kgs and 3 kgs. We took 2:3, right? We have to invert the weight ratio, Ankur. 14, we actually got 14 in the previous example because we took the weight ratios as 3:2. Now it's 2:3, right? So you got 16, which is the per kg cost, right, for this 5 kgs, right? That is what you have to remember here. So in the next step, you will say 16 and 30, where 16 ka weight is 5 and 30 ka weight is 5. So that's 1:1, right? You invert it, it will still be 1:1. So you basically have to find the number that's halfway between 60 and 30, which is 23, right? So you can still use the number line. You can't use it in one step, right? In certain questions, it might be useful to take the number line in 2 steps. In certain questions, just using the formula might be faster. You will get a better bearing on this when you try both, right? This is something that I tell people, right? To always fall on the right approach to a question in the exam, right? It makes sense to actually try to solve simple. Why added 2 plus 3? See, that's what I said, right? The 16 per kg was the weighted average, right? It was the per kg cost of this total 2 plus 3, 5 kgs of mixture. You first mixed 2 and 3. You got 5 kgs of mixture, which had a per kg cost of 16 per kg, right? So that mixture is being mixed with the 30 now, right? Okay, perfect. Now the question of which one to use, practice when you're practicing, try solving question in multiple methods, which is a really good way of strengthening your concept and also getting a better idea of. I mean, you'll instinctively get a better idea of which approach might work better in the exam the more you practice it, right? So this is basically what you do when you have 3 components. Now let us come back to this question, right? You have dots, you have 4s, and you have 6s, right? Let's not worry about the dots now, right? we know that he hit 3 times as many sixes as fours. So the weighted average of the fours and sixes alone that he is hitting, right? Assuming if you ignore the zeros of the dot balls that he faced, his weighted average would have been, I mean his strike rate would have been the weighted average of 4 and 6, where the weights are 1 and 3, which means you have to divide this distance in the ratio 3:1, right? So that gives you 1.5 on this side and 0.5 on this side, which gives you 5.5. Right, 5.5 runs per ball, which is basically a strike rate of 550. Right, now because of the dots as well, that strike rate is reducing to 250. Right, and from the dots he's getting nothing. So this 250, it's a slightly unnecessary question. I agree. Some people are probably thinking why I'm doing this. Right, so 250 is a weighted average of 0 and 550. That's a distance of 250 on one side and 300 on the other side, which is 5:6 ratio, which means 6:5. Yeah, invert the ratio. That's the thing which you forgot. 6:5 is the ratio, but the question was what fraction of the total balls were dot balls, right? So the answer to that is basically 6/11. 6/11 were dot, 5/11 were boundaries, and out of these boundaries, 4s and 6s were in the ratio 1:3. Any doubts? I'm guessing somebody will have a doubt on this. Guys, does this make sense, or does it only make sense to me? I sometimes wonder this. Is it fine, everybody? I got, okay, you got, okay, Del, can you tell me how much of it you understood? Do you understand the part that his strike rate from the 4s and 6s alone, not including the dots? Suppose you take all the dots out of the equation, he had only 4s and 6s and no dot balls, his strike rate would have been 550. We're basically trying to find the weighted average of two components. Del, is it fine? Okay, yeah, so you get 5. Okay, Sai, did you mean that you also got 6/11 or something else? If somebody can unmute and talk to me, that'll be better, okay? Because it's hard to keep track of what is happening. Del, how much have you understood? You understood the part where the weighted average of the first two components, the 4s and the 6s, becomes 550, 5.5 runs per ball, and that becomes 5.5. Okay, so then 5.5 is runs per ball, and strike rate is counted as runs per 100 balls, right? So that translates to 550. That was your doubt, right? Or you can also say, you can actually directly say 5.5 runs from per ball and 0 runs per ball, giving an average of 2.5 runs per ball. It's not going to make a difference in the final answer, right? A strike rate of 250 is 2.5 runs per ball. Does that answer your doubt, Sunil? Yes, and then you understood the part where, one second, you understood the part where from the boundaries alone he's hitting 5.5 runs per ball, right? And now because of the dot balls, his average is reducing to 2.5 per ball, which is what is given as 250 strike rate, right? So 0 and 5.5 have a weighted average of 2.5, which is a distance of 2.5 on one side and a distance of 3 on the other side, which gives you a ratio of 5:6. Sorry to the other guys for repeating it over and over again, right? Give me a second. So 5/6 is the ratio of dot balls and boundary balls. No, 6/5, sorry. You inverted 6/5 is the ratio of dot balls and boundary balls, right? So 6:5 means 6/11 were dot, and the remaining 5/11 were boundaries. Is that fine, Del? Okay, cool. Yeah. So we've looked at questions directly based on allegation. I'm going to show you a couple of questions where you can use it to speed up your process in other chapters, right? One of my favorite questions. Yes. Ping yes if you get the answer. Anyone? 16%, perfect. Right? The answer is directly the weighted average of 10 and 20, where the weights are 4 dozen and 6 dozen. This is not required to solve the question. Deliberate distraction. So if you went in the direction of 1 dozen is equal to 60 or 1 pen is equal to 5, that is precisely what I wanted you to do. Right? 600 is 600 is not required to solve the question. Right? This happens a lot in quant, in cat. Please understand. Right? So you remember, I mean, repeaters at least might know that there was a section, I mean, as part of data interpretation you also have data sufficiency questions. You will see this in the content, right, in many of the cat content. Data sufficiency questions, that nowadays they're not asking it directly, but they're actually testing how good you are at data sufficiency by indirectly giving you unnecessary things, using which you will still get the answer. Right? You will say 1 pen is 5, okay, this will be 5.5 per pen and this will be 6 per pen. You can calculate big numbers and get the answer after 2-3 minutes. You can still get the answer, right? But if you know that this is irrelevant to the answer, you will save a lot of time, right? So data sufficiency is being indirectly tested in quant questions by giving extra information, right? We must learn to ignore that, right? Right. The answer, as I said, is just the weighted average of 10 and 20. We have done this a few times now already. 10 and 20 where the weights are 4 and 6, you have to divide in the ratio 6:4, right? So you'll get the answer 16. Cool. Others? 18. Yes, Del, do you want to speak about this 18? Or did you understand the solution? Yeah, do you have any doubt regarding how I got 16? Del? Yes, tell me. Can you tell me where exactly you have a doubt? Hello?
Hello.
Yeah, tell me.
Sir,
Yeah.
uh, I'm assuming overall profit as a X%. Okay. Then,
Okay.
with your what you call line approach, I'm making as a X minus 10 and 20 minus X, and then I'm comparing this ratio in form of X is equal to 4.
20 minus x is equal to x by x minus 10 is equal to
4
what are you getting?
by 4 by 6, like that.
4 by 6. And what are you getting is x? 20 minus x 4. This should give you x is equal to 16. If you got 18, you made a calculation mistake.
Okay, thank you.
Yeah. Okay. One more from profit and loss. Actually, would you guys like to just take a look at all of these, or do you want to do these one by one? All of you, what would you prefer? Guys, should I give you the set of some 10, 12 odd questions, or should we discuss them one by one? Or should we discuss other doubts? Yes, how do I share the whole set? You can't see the whole thing. Okay, we already discussed the first 3, 4. Cool. Yeah. edit this. Anybody is getting stuck on any problem, feel free to unmute and ask. If you have any other doubts in general in allegation, feel free to ask. %7.5%. Which question are we talking about, Del? Question 7. Correct. 7.5. Perfect. If the answers on the right, on the left side, right? I put them on the margin. First timers, I'm guessing you will have some doubts because these are questions of other topics as well. Feel free to ask. Right? Hello? Guys, no doubts? Any question here that you want me to do? Can you please explain question 7? Okay, question 7 is a little complicated. Guys, I'm going to switch to my paint. Out of 8 articles bought for 353 were sold for loss of 5 and remaining 5 are sold for profit percent. Okay. Now, the idea is that we already discussed how the overall profit percent is the weighted average of the individual profit percents, and with the loss, you'll just take it as a minus, as a negative profit. So loss of 5% is actually -5. So what you have here on our number line is 3 items. Was it 3 items? Give me a second. 3 items were sold for a loss of 5%. So the number that you put on the number line is -5, and 5 were sold for a profit of, we don't know. We also don't know the weighted average. That's how this question is different. But we have said that this is numerically double of the overall. So I'm going to take the overall as x and this is 2x, right? And we know that this distance is to this distance is 5:3. So x plus 5, this distance here is actually x plus 5, right? X minus -5. X plus 5 by 2x minus x, which is just x, is equal to 5/3, right? This distance is x, this distance is x plus 5, and there in the ratio 5:3. So x plus 5 by x is equal to 5/3. If you solve it, you will get 3x plus 15 is equal to 5x, 2x is equal to 15, x is equal to 7.5%. So the profit for the remaining 5 are actually 15, and the weighted average is 7.5. Is that okay, Rudra? Yeah. Back to the questions. Anybody got the last one? X plus 5. Huh. See, okay. Mohanish. Okay. The thing is, your 0 will be between minus 5 and these are both profits. We are told that the overall is profit and for the remaining 5 is also profit. So those are both positive numbers and the 0 is lying between, right? So 0 to x is a distance of x, 0 to minus 5 is a distance of 5. So the total distance is x plus 5. Right? Is that okay? Yeah. So taking the distance ratio and equating and getting the answer. Okay. Any doubts? Any of these questions? Anyone? Still doing? 9. Question 9. A principal of 1 lakh is split into two parts, invested into schemes which gave 8 and 10. Amounts to 118. Right. Now, see here the idea is that the overall rate of interest, right, is the weighted average of the individual rates of interest. So for a moment we ignore the fact that it's split into two and we just look at the amount. 118 was it 400? Yeah, 118,400 was the amount and principal was 1 lakh, which means that the total SI was 18,400 for 2 years, right? This will give us a rate, right? You can use a formula. R is equal to SI into 100 by P to T, which will give you 9.2%. Yeah, that should give you 9.2% per annum. If you're not sure, you can just verify that by calculation. So basically what you have is 8 and 10 give a weighted average of 9.2, right? That's a distance of 1.2 and distance of 0.8, which are 12 is to 8, which is in the ratio 3 is to 2, which means the principals when the ratio 2 is to 3, and that's your required answer, right? The effective rate of interest is the weighted average of the individual rates of interest where the weights are the principals. Is that okay? Yes. Now the alternative algebraic approach would actually involve doing something along these lines. You will take the two parts of the principal as 100x and 1 lakh minus 100x. Right? You would say 8% of this is 8x. You would say 10% of this is 10,000 minus 10x. Right? And these are the interest for 1 year. For 2 years, it will be double of that. Total interest for 2 years will be double of that, and that will be equal, one second. That will be equal to 18,400. If you solve for x, you're going to get 1 lakh will be split as 2 to 3, 40,000. So you will get x is equal to 400. If you don't trust me, you can calculate and find out. That will give you 100x is equal to 40,000. The first part of the principal and the other part will be 60,000 ratio 2 to 3. Right? Then you have to then convert it into a ratio. Right? The question was basically asking how was the ratio split? I mean, how was the principal split? Right? So the number line will directly give you the ratio. Is that fine, everyone? Yes. What are the other questions? 52 is, I mean, the question 10 would have been straightforward, right? It's just the weighted average of 40 and 60 where the weights are 2 and 3. Question 11 was a bit of a twist in that, right? Because the weights should be time, right? Time is directly given as 2 and 3 in the previous question. Here you can find the ratio of time using the ratio of 1 second. Right. Okay. Let's discuss question 11 and then 12. First of all, does anybody have a doubt with question 10? 10 should have been fine, right? Anyone? Okay, I'm going to move to question 11. Right? The thing here is that you are given 30 and 60 and you have to find the weighted average 30 and 60, but you need the ratio of time to find the answer. Right? What we have is that I went from A to B and came back, so the distance is equal. So when distance is constant, the time ratio is the inverse of the speed ratio. Right? Time and speed are inversely proportional when the distance is constant, which will give you, when the speed ratios are 1:2, the time ratios will be 2:1. Right? So those are the weights that you're going to use, 2 and 1, which would actually again go back to 1:2 as a distance ratio. Right? So that will give you 40 as the answer. You can use 2AB into A plus B. No issues. 40 is the answer. Is that fine? Question 12. Anybody got the answer to question 12? I'm just going to copy it here. Ready. Yes. Cool. Should I explain, or are you guys still trying? Or are you close to getting the answer? Sure. Take your time. Okay. Can you, do you want to share it with me? What you did? Is that okay? Yeah, you can unmute yourself. Tell me.
Hello.
Yeah, tell me.
Yeah, first of all, I took male as X and female as Y,
Okay.
and then I increased X by X to 1.25X as it is increased by 25% for male.
And this
And
would
then
have
I
become 2.
increased to Y, yeah. And
Yeah.
the total increase was 1.4 X plus Y.
Yeah. So you will say that 1.25 x plus 2y is
Y.
equal to 1.4 x plus y.
Yeah,
This would have given you x by y.
yeah. Y is equals to X by 4. That is what I'm getting.
X by y will be 4 basically, right?
Yeah, yeah. So
Okay.
after that, it is saying that from 1.25 it increased to for 30%. So it increased to 1.625.
1.625. Fine.
And then y
And
increased again to 100%, so it will become 4y.
4y. Okay.
Yeah. And so by adding this, I am getting as 2.625x total.
Right. So
X.
yeah, you will convert everything in terms of x and you will get the answer. Fine. So what you've done is essentially the same, but we can simplify it a little further if you use the number line, right? Uh, Other people, can I give the solution now? The answer is 50%. Guys? Yeah. So see, the thing here is, in the first part I'm given R1 and R2 and RW, which will help me find Q1 and Q2, right? So you've got 25 and 100 giving in a weighted average of 40. That's a distance of 15 and a distance of 60. This will directly give me 1:4, a distance ratio of 4:1, right? Now the place where our friend Mohanish got slowed down is he continued to use X and Y. You can actually take the numbers as 4 and 1, or you could have at least taken it as 4x and 1x, right? You found 4:1 ratio. If you've taken the numbers as 4x and 1x, it is actually not required. 4:1, 4 and 1 as absolute numbers are good enough, right? I'll explain that in a second. 4 and 1. If 4 is increased by 25%, then that becomes 5, and 1 increased by 100%, that becomes 2, right? And so the overall strength increased from 5 to 7, which as you can see is clearly a 40% increase, right? This is what is given to us. We use the 40 to find this ratio, right? Now we have 5 and 2, and 5 is to be increased by 30%, and 2 is again increased by 100%, which will basically give me 6.5 and 4. So the sum is now 10.5. You just have to calculate this, which will turn out to be 50%, right? The other thing is you can still use alligation from here, 5 and 2, right? You take the 5 and 2 and you take the 30 and 100, right? So you're trying to find the weighted average of 30 and 100 where the weights are 5 and 2. So that gives me a distance ratio of 2:5. The total distance here is 17. So that gets split as 20 and 15, right? And 30 plus 20, this value here will be 50, right? So it's just 2 steps of alligation, which would be the faster way of doing this. Just this diagram here will give me 4:1. You also know that it becomes 5:2 after that increase, and you can use 5:2 and the given 30 and 100 to find the answer is 50. Does that make sense? Any doubts regarding that, guys? Anyone else? Is it fine? Hello. Other people, no response. Yes. Now, one important thing, I talked about why I can take 4 and 1 instead of assuming a number. This is a very important concept here, right? If I had taken 4x and 1x, I would have gotten 5x and 2x. I would have gotten 6.5x and 4x. I would have gotten 10.5x and 7x. When I tried to find the percentage change, right? Percentage change is changed by original, right? That will be 3.5x by 7x, right? The x will cancel, right? So when do we know that the x will cancel and we don't need x? And when do we need to take x? Is a very important question, right? Now it's very simple, right? You understand the difference between fractional changes. This is not directly from alligation, but since I have 5 minutes, I'm going to explain it. You have fractional changes and you have absolute changes, right? When I say that the CP increases by 5, if the CP is increased by 5 rupees, that's an absolute change. But if I say the CP increased by 5%, that's a fractional change, right? So fractions, ratios, and percentages are all fractional changes or fractional values, while something like 5 rupees or 10 kbs, those are all absolute values. Now, if any question is asking, giving you fractional changes and asking for a result in fractional change, that's a question where you can directly take a number instead of taking a variable, right? For example, if I say if my markup, this is going in another direction. Okay, quickly, what is the percentage increase from 400 to 500 and the percentage decrease from 500 to 400? $25 and 20, perfect. So the increase is 25% and the decrease is 20%. Now for any change like this, A is being increased to B and B is being decreased to A, if I have an I percent and a corresponding D percent, right? Suppose the question says a certain number A is increased by 25% to get B. What is a percentage reduction to get back to A? The answer here is, this is an example of a place where I can just say let A be equal to 100, right? Because they're giving you a fractional change and asking you for a resultant fractional change. This is a very important concept, right? I cannot talk about it and do justice to it in 3 minutes, but I thought it was important to mention, right? Please note this, right? When you see questions, notice where there are questions that are dealing only with fractional changes, right? And the answer, and therefore the 20 will depend only on the 25. If I had taken 100x, all the x's will cancel in the end. Right? This is a very important concept. We'll discuss in more detail in a future session, but note this. Okay. Any other doubts? Feel free to ask. Allegation or outside allegation, general cap prep technique, whatever it is. Anyone? Anything? Yes, tell me, tell me.
Hello.
Yeah, who is this?
Vishwas, sir.
Okay, what's your doubt? Cool, cool. Tell me, what's your doubt?
While preparation of DI, I am getting some kind of difficulties with respect to calculation and understanding the DI
Right.
core part
See,
of the.
so first of all, let me ask you: is your issue with? I mean, do you have an issue with speed, or do you have an issue with getting the answer?
Both, sir, both.
Right. So if you are getting an issue with, if you're having an issue with getting the answer, then you might want to work a little more on your comprehension skills, right? One general misunderstanding that people have is that comprehension is required only for RC passages, which is entirely not true, right?
Okay.
You right. So work on your comprehension, which means read a lot, right? There's nothing else you can do, right? And as far as calculations are concerned, see, in DI there's something called there are a few trade-offs in this competitive exam scenario, right? In DI this is something called a speed accuracy trade-off, right?
Yes.
Which means that, I mean, it's also true to a certain extent in quant as well. Yeah, we'll take all those questions, right? Give me a second. So suppose you have a question where you have companies A, B, C, D, E, F, or maybe schools A, B, C, D, E, F, and they're giving you number of students who appeared in the exam and number of students who passed in the exam. Suppose, just hypothetically I'm giving it, right? And you've got big numbers. Maybe not schools, maybe districts in the country, right? You've got big numbers here. All numbers are big, right? You don't need to calculate. And maybe the question, hypothetically, let the question be, which district? So you have all these 4-digit or maybe 5-digit numbers. Which district has the highest pass percentage? This could be a question, right? Now don't calculate accurately for everything, right? I'm just gonna first subtract, delete this, right? Suppose you have these numbers, big numbers are coming here, and you're doing a rough calculation, a very rough calculation with respect to all of them. Suppose you get this is approximately equal to 0.4, this is approximately equal to 0.5. Now this is entirely out of the running now, right? You basically need an algorithm to make sure you do a fine calculation only with some questions, right? So later you get third one, you got it approximately equal to 0.2, next one approximately 0.5. Right? So you need a finer calculation to compare between 0.5 and 0.5, but don't do it, right? Just leave it there. And what if the next one is going to be 0.7 and the last one is 0.1, right? The finer calculation required to differentiate, maybe this is 0.52, when you do a finer calculation, this is 0.53. This finer calculation is absolutely not required to get the answer, because the rough calculation itself is negating both of these options, right? You get the idea. So basically when I said speed accuracy trade-off, to get 0.5 versus 0.4, you can do a very rough calculation, right? But if two options are close by and you need to calculate them with more accuracy to find which of them is slightly bigger than the other, you need a more fine calculation, which might take you a little more time, right? The answer is not to take that on-screen calculator and calculate accurate percentage for everything. That's actually going to be a waste of time, right? If you're a repeater, you'll know that on-screen calculator is practically useless, right? You don't get to use the numpad on the keyboard, so you have to click on every every single number with a mouse, right? So that's not going to be save your time. It's going to waste your time, right? In many cases, right? In quant, I don't even recommend touching the on-screen calculator. You won't need it in the quant section. In DI, try to use it as sparingly as possible, right? So this was just an example to show you, right? I can do a rough calculation here. I know to differentiate these two, I need a fine calculation, but I don't do it. I hold on. I hold on to those 0.5 and 0.5 and see if I'm getting a next option that is negating both of them. Right? Once neither of them are the best, I don't need to find which is the second best. Right? So my answer is directly E with only rough calculations. But if E turned out to be 0.3, then I have to do a fine calculation to find which of these two is higher. Right? So try to hold off doing the fine calculation. Right? Eliminate options by using rough calculation. This will increase your speed a little bit. Right?
So
one thing you can do.
On-screen calculator or not?
Depends. There are situations where you need to use it. There are situations where you don't use it. Right? For example, addition of 2 4-digit numbers and all. Don't do it. From a DI point of view, you can just ignore the tens place in the. Suppose you have 4,583 and 7,517. Right? This is basically 120, 100. Yeah, I instinctively took it as 120, but you can practically just take it as 4.5K and 7.5K and say the total is 12K, which is I mean the difference between the correct answer and the wrong answer, you're looking at a less than 1% error rate, right? The error rate that you can tolerate depends on how widely spaced the options are, right? These are things that you need to understand with respect to DI. Right? I can do a rough calculation when the options are widely spaced. I might need to do a fine calculation when the options are close by. Right? Also, if the options are very close by and I need to do a fine calculation, maybe that question is going to take more than 2 minutes. In that case, I have the option skipping the question. Right? People don't realize in DI and LR especially, it's absolutely crucial that you pick the right questions and leave the ones that are going to take you more than 2 or 3 minutes. Right? Yes.
Thank you.
Is it fine? Yeah. You're asking?
So,
yeah. Tell me.
yes, sir, I have a question. That
Yeah.
how many questions does CAT give from the numbers and the geometry especially?
Geometry is going to be somewhat big. Numbers not so much. I think in CAT 2015, I wrote in the morning session, there is only one question that was based on remainders. From the whole, I mean, I don't know about this factors or LCM or all, I didn't notice. But from the remainder theory side of it now, there is modular arithmetic and they're asking, so if you go to any forums or look at past papers, 2 raised to 17 by 108, what is the remainder? They stopped asking this. Right? Last year there was nothing like this. Right? Don't worry about this side of number theory. Right? Learn some basics. Like, see, as far as this is concerned, there are some basics of modular arithmetic that will help you solve maybe the easier questions and the medium questions, right? And then there are a bunch of obscure theorems, Euler's torsion function, Fermat's little theorem, so many other theorems in there, right? You cannot really cover the whole thing exhaustively, right? If you want to try to cover maybe some of them, then that's fine. But my approach has always been to just be sure of this part, and also be sure of, when you get a question, you should be able to identify whether it is going to be a somewhat basic question or going to be a complicated question, right? It's all about question selection. You have to look at each question one by one, right? So you have, see, what you need to understand, ROI is very important, right? Your return in both preparation as well as test taking, right? Now, in preparation, the return is the number of questions you can expect while the investment is time required to cover a chapter, right? RC. See, I'm not an expert in RC. I'm an expert on question selection in RC. That's basically how I get my good percentage, right? See, what I was trying to say here is, please understand that every question in test, from the test taking point of view, every question is +3 - 1, except for some questions which are non-MCQ and will be +3 - 0, I mean +3 and 0, right? So the return is the same for every question, while the investment is grossly different, right? Now, if you get a really tough question, the thing to do is to not panic. The thing to do is to simply skip the question, right? You must be a good judge of the difficulty of a question to ace this exam, Right? It's not about learning everything. Learn 50, maybe 60% of the syllabus, and you can probably still get a decent percentage, pretty decent percentage. But you must be know what other remaining 40% I don't know, and what is a tough question, what is an easy question, right? That's very crucial. Hello. Yes, Rudra, you are asking about RC. I'll give you one simple tip, right, which is very useful. I basically do not commit to an RC passage. I don't read before doing the questions, right? What I do, you are talking about RC prep or how to, Rudra, hello? Were you asking about how to prepare, how to give exam? I can give you a tip on how to give an exam, right? What to do is to not read the passage first. This is something that I do. I mean, I'm not saying that everybody does this, right? So don't read the passage first. Once you read the passage and you see those, really confounding questions that CAT likes to throw at us, you will have a lot of doubts about what is there in the passage, right? Read the questions first. I like to just simply split them up into single para questions and multi-para questions, right? Simple enough, right? Now I directly go to the questions. Now something like when the author is referring to such and such phrase, what does he mean, right? This is a single para question. You can now scan the entire RC and find this phrase, read that sentence, read the sentence about it, and you probably get the answer right. Right. On the other hand, you have these multi-para questions where the question, the question setter is asking, out of the following 4 points, A, B, C, D, which of these do you think the author agrees with? A will be in paragraph 1, B will be in paragraph 2, paragraph 3, paragraph 4, and the options will be like only A and B, A, B, and C, right? A and D. Now, this is going to, not only is it going to take a lot more time, you will probably get this wrong itself, right? I just basically stay away from these questions and do only this. And you could, if you practice this approach, you are looking at maybe reading 25% of the passage and solving 75% of the questions, right? Which will give you plenty of time to do the other parts, the non-RC parts of the section, right? Please understand that nobody is getting everything right, right? Section-wise weightage for quant section, I'm not sure about these things. Okay, just understand that I don't have the weight of an institute behind me, the power of an institute behind me, right? ZAT, I've actually not written ZAT at all till date, so I don't know. I only know that ZAT questions are usually tougher. You were asking about the weightage in quant section. I'm not, instead of answering it directly, I'll tell you exactly what to do, right? You want to learn the high ROI topics first, right? Which is why we started Alligations, and we'll be continuing basically with ratio proportion, percentages, profit loss, and interest, both SI and CI. So this is what I've been doing with my students. I teach this first. I call this quant stage 1, and then I start DI, right? Quant and then DI. So what you will see is that these 5 chapters together take care of the entire knowledge requirement for DI, right? So this has the highest weightage because it's tested in quant as well as DI. Now after introducing DI, looking at all the basic kinds of graphs and tables that we have, I go back and finish the arithmetic side of quant, which would be time and work, time, speed, distance, and average, right? These 8 chapters, let's call it quant 2. Quant 1 plus quant 2 basically covers the entire arithmetic side of quant, which is approximately 40% of the number of chapters, but it will give you more than 40%. Approximately 50% of the questions will come from here, right? And with respect to the other areas, it depends on your skills. I mean, arithmetic is crucial. Don't ignore any part of it. Learn the whole thing. But beyond that, don't learn everything. You won't get the time to utilize the entire knowledge. Is what I say. What I've personally felt. There's something called law of diminishing returns. Right? I basically give this lecture to everybody. Law of diminishing returns is something which you have in econ, right? Where you say that if you have multiple factors of production for producing something, right? And if only one factor of production is increasing while the other is remaining constant, your total output will reduce. The increase in your total output will reduce, right? To put it in terms that are relevant here, you need both knowledge and speed to do questions, right? You have a 60-minute quant section with 34 questions, right? And let's say that you're currently at a speed where you can do 3 minutes per question on average. you are not going to do more than 20 questions, right? What is the point in learning like 80% or 90% of the syllabus, right? So improvements in both of these should go hand in hand, right? Now if you're currently at 20 questions out of 34, that requires only 50% of the syllabus, right? Beyond 50%, if you're covering more syllabus without improving your speed, your output will not increase, right? Your output could probably decrease because you will start running questions and dropping it, right? So this is basically what I tell people. Don't learn the whole thing, right? You can broadly put it into 4 areas, right? You have an algebra area. What comes after arithmetic comes into 4 areas. Algebra, which is quad, functions and graphs. Please stop me if I'm saying something that you don't understand. Logs and inequalities. This is what is there in the algebra section. Then you have the geometry section, which is basically geometry plus trigonometry plus mensuration, right? You have your combinatorics, which is PNC, probability, you could say binomial. Technically, I mean, could be there. One question might come, I don't know. Set theory also comes here, right? You also have what is left? Number theory. PNC, let's take it chapter by chapter, okay? We can't do everything in one day. Number theory has your numbers, your modular arithmetic. Numbers means everything from LCM, HCF factors, everything, modular arithmetic as well as APNC, right? Now, I would suggest that you pick and choose from this. There are areas that you're good at, areas that you're bad at. Identify them, maybe learn 2 out of these 4 areas broadly, right? And become good at doing it. Right? Don't, I mean, learning everything and being able to solve every question in 3 minutes is useless. You're only going to do 20 out of those 34 questions. Don't do that, right? Learn maybe 2 out of these 4 areas and do them well. Again, depends on individual abilities. If you're very strong in logic, I would recommend PNC and probability, right? If you are more strong on algebraic rigor, clearly you should take algebra, right? So individual preferences may vary. Figure it out. Maybe take 2, or at more, I mean, if your speed is higher than that, maybe take 3, right? You need to know some, I mean, I collected numbers on overall score versus percentile, and 145 is basically 95 percentile last year. Now 145 is like, if you get 55 attempts and 50 right, that is 145 marks, right? So people don't realize how few questions they have to do to get a decent percentage, right? Then they panic. They see 100 questions in 180 minutes and they panic and they try to do everything, right? So if you're trying to do all 100, you have 1.8 minutes per question, and if you have 1.8 minutes, basically after 1.2 minutes you will start panic, right? But if you set yourself a target of 60 attempts, you know, hoping to get a 95, you will get 3 minutes per question, and you'll probably do 3 minutes per question very easily, right? Just understand that probably the number of questions required for your target percentile is a little less than what you thought it was, right? Okay, any other doubts? Hello, anyone? We just answer the question, right? With respect to yeah, with respect to what to read, I don't want to suggest anything. I really am not an expert on the verbal section, right? I've been scoring okay with percentile wise because everybody scores in the same range, not because I know the answer to everything, right? It's mostly about good question selection, right? What you need to do, right? Not just with verbal, but it's most important for verbal, right? Yeah, sure. So that's it basically. We are running out of time. We are already late. More of these questions we can probably answer in the next session, right? That's it for me. My feedback to the students who are here, it would have been better if you talk up a little bit more. Even though we told you to mute yourself, that is necessary for taking the session, but becomes a kind of monotonous when I'm just listening to myself and nobody else, right? Feel free to ask more doubts in the coming sessions, right? Utilize this opportunity well, ask all your doubts, understand the concepts very well, right? There's a question on shortcuts. Should I be depending on shortcuts? Like what I like to say is that shortcuts are a marketing term, they're not an academic term, right? Think of it as optimizations. Optimizations that come from really understanding your topic, right? So you know, once you really understand a topic, you really don't think of shortcuts as shortcuts, right? It's just things that you know that this is going to happen this way after 4 steps. So I'll directly write the result that comes after 4 steps. It's really, I mean, shortcuts give the wrong impression. The term shortcuts gives the wrong impression in the sense that people get an idea, at least some students will get the idea I can solve this without understanding, which is not really the point of it, right? So really understand the topic in depth and these shortcuts will come to you yourself, right? And usually things that you don't understand how they work, you will forget, right? If you try to understand the shortcut without really understanding why it works, how it works, you will forget it, right? So make sure you understand everything in depth, right? Ask all your doubts. Let's make the session a little more interactive. That's it for me. Have a good day. Yeah. Shilpa, are you here?
Yes, Sanjit, I'm here.
Yeah. So shall I close it?
Yes, Sanjit. Just
Yeah.
you can just log out of the session, Sanjit. Thank you.
Sure. Thank you.